Hello, and today we're going to be looking at accuracy of a statistic. So when you're doing statistics, obviously you are measuring some characteristics within a sample, and then you want to try and extrapolate that and extend it into the population. So you use that for estimation purposes. But then you find that accuracy is one of the major things in statistics. So the accuracy of a statistic is an indication of how well it reflects the true population statistic. For example, if we calculate the average, the mean of a sample, can we really say that it represents the average of the population? So accuracy is very important in that regard. So there are two main accuracy problems that we have, where, for example, an effect exists in reality, and then there are times where the statistical test that you're performing can find an effect as well. So we need to be able, the best situation is if a statistical test corresponds with what's happening in reality. If it's yes and yes, then you know that your model, your test that you used is good because it's corresponding with reality. Right? And then if your test doesn't give an effect, but you find that the effect exists in reality, that means that there's a power problem. Your test is not powerful enough. So you have to increase the power of your test in order to be able to excavate and show that effect which actually exists. And then, if your test shows a problem, but the problem doesn't exist in reality, then that's a problem, right? Because what you're doing is you are saying there is a problem when there is no problem. So that's a false positive, right? And it's called the significance problem. And then, if there is no effect, and the test says there is no effect, that means that it's perfect. So these two, the ones shaded, are the desirable ones. And the two problems, power and significance, are explained below here. So the significance problem, this one, the false positive, also known as type 1 error, is often denoted by the alpha, which is the percentage or chance of a false positive. So here, you can just increase your risk level, your alpha level. You can increase it or decrease it. So by altering it, you are playing around with the significance of your test, because you find that if you are doing it at 90% confidence, so you have too much room for error, which is 10%. And then if you have a problem where there is an effect and your test is not showing it, so the power problem usually is solved by increasing the size of the sample. That is one of the many ways for solving the power problem. So go and research further on these effects and that deal with the accuracy of the statistic, and understand them so that when you're doing statistics, you won't fall victim to such mistakes. Thank you.